So we've got a very exciting session now. We've got networking with David, and then we have some security. And then we'll have another lunch break. And after lunch, we're going to step it up a notch. We're going to get some customers on stage. We have RBS and we have WorldPay. So make sure that you enjoy your lunch, you talk to the experts. Perhaps you go to the silent theatre and then get back in here to hear what Royal Bank of Scotland and WorldPay are doing with their automation inside their enterprises. So I'd like to hand over now to David to talk to you about network automation. David.
Can everybody hear me all right? I guess so. Pleased to meet you all. I'm David. I work for Red Hat in France, where I'm a solution specialist, exclusively, mostly focused on Ansible now. And I'm going to talk to you about network automation with Ansible. So, thing is, how many of you are network experts or consider themselves like network admins? Yeah, so quite a few of you. So I'm not a network admin myself, although as a sysadmin, I've always been doing network administration. And this is something I'm going to touch a little bit about because what we feel is that managing networks haven't changed since a very long time. And why is that? One reason it hasn't changed is because of the tools that we use to manage networks. So those tools are like usually logging into a network equipment and using the CLI. And this CLI is going to be proprietary to that specific vendor. Maybe sometimes you have a managing tool for all the equipment of a specific vendor, but it's not going to be cross-vendor. You don't have like this single glass of pane. You can't really automate things easily. Most of the times you don't have an API. And these tools, the fact that they are like very specific to their vendors, well, essentially it kind of siloed the network teams outside of the rest of IT. And you're always like reaching out to network, and network is reaching out to servers or to, so like there's this kind of silo thing going on for networking. And sometimes, it's also the interest of the network team to like have a stronghold because it's really critical also. So you don't want to be messed up by the other people. So thing is that in IT, things have changed quite a bit. We were automating more and more. Take, for example, software delivery, the way we deliver software, the way we're able to do CI/CD, the way we ship software to production with integrated testing. Although this is certainly not like brand new, it accelerated quite a bit. And that's, the DevOps movement. And the network teams and the network ops and even like the network infrastructure has been lagging a little bit behind. So they've been siloed out of the new movement. So this being said, we're not going to say, yeah, all of networks has to be DevOps or Net DevOps or some other combination of those terms right away. But probably there is a way to, make some of the network that we're doing today a little bit better and a little bit integrated into the new way of doing stuff. So that's what we're also about with Ansible networking. We're trying to provide a way to move network into the new modern way of doing stuff, which is good for network, but it's also good for what people use network for. So how are you going to do that with Ansible? Well, it turns out it's quite easy, as everything Ansible, and you can start small. That is, you can automate some of the things that you're doing today very easily with a very small effort, very small Ansible effort. But when you do this, and for example, you could be automating some of the tasks that you do day to day, like creating VLANs or having a specific configuration for a switch dumped to backup, that kind of thing. So some of the day-to-day operations you can automate, and when you automate those, then you can slowly grow into a more complex and more integrated network automation workflow. That is, each single discrete task that you're going to be automating, then you can build into an end-to-end integration where network is part of a broader automation scheme. And then when you've done that, then you can scale it out to like all of your network, multiple data centers and so on. The logic behind automation, behind network automation with Ansible, is to treat network infrastructure as code. So, or as we say, Ansible is not code, maybe network infrastructure as YAML. So that's a quite powerful paradigm. So what it means is that you're going to represent your network topology in a YAML file. You're going to represent your network configurations that apply to that topology in also a YAML form. And all these are going to be version controlled in Git or some other source controlled management system, but we usually find Git on the field. That's extremely powerful because it means that you're going to be able to validate that the configuration you have in place is correct. You're going to be able to make incremental change to that configuration. You're going to be able to apply those changes to a small part of your network or to maybe different switches that are at the same leaf level. You can do slices of your network and apply configuration. You have traceability for everything. You can run management jobs. You can ensure compliance. So the whole paradigm of infrastructure as code applies to networking with Ansible. And obviously, you don't have to be at that level just when you start because it's a brick by brick kind of progression. So you've probably seen this one before. I'm going to go now into the more technical part where I'm going to be all about modules. So like Ansible really works on modules. So we have the inventory part. The inventory part is where you have your network infrastructure. And the module is the action part where you act on this infrastructure. So first of all, the inventory part. How do we connect with Ansible to these nodes? Well, see, since Ansible 2.5, we connect using a connection method called network CLI. It's a bit different from what we do with server nodes, because server nodes, we're able to connect to the node and to run on that node the automation. Well, you don't connect to a switch to run a Python package, right? So with Ansible, you're doing everything on the Ansible run host, and then you're running those command remove to the network nodes that you manage. So that's the specific connection mode that we use to manage device with Ansible, network device with Ansible. So when we connect to those devices, we then use modules to action stuff to apply the configuration on the network devices themselves. And all the platforms, all the things that we can do with Ansible on the network infrastructure comes from the modules the network modules that Ansible ships with. And as it turns out, there's quite a lot of them. There's a huge effort going on to make Ansible a massive automation engine for networking. So we have platforms, 50 of them, a huge amount of modules. I'm going to describe them very quickly. And we also now have specific roles for networking. And some of you may know that roles are like libraries for playbooks, but they can also come with modules, and I'm going to touch a little bit on that. So not only do we have a massive number of modules, but we're also adding more and more quickly. So there's a huge effort, and you've seen previously the number of modules that we ship with Ansible, but also the effort on specific network module is quite heavy. So there is a lot of action going on with Ansible networking, and with some reason, because it turns very powerful, as you're going to see, I hope. Those are some of the platforms that we support with Ansible. So the network platforms, so there's a ton of them. Some of them I've never even seen in my life. Some of them are something very common, like big IP F5 switches, and automating big IP load balancing switching is very easy, and it's something very useful because it's something that you do day to day, like an application, it's new, you need to add it to the virtual pools and so forth. So that's one of those things that you can quickly gain automation value on. Also for other load balancers, obviously. Those network modules are actually supported by Red Hat. There's subsets of the network modules that are officially supported by Red Hat, and you can with Ansible Engine, you can get if there's a problem, you can get debug support for a specific type of module for a specific type of Cisco OS, for example, right? So that's good value because, again, network infrastructure is critical, so it's probably important to do that correctly. Here's an example of how you use a network module with Ansible. So for some of you that have never seen Ansible, they already know what this is doing. It's running a command on an iOS device, which is a type of Cisco OS switching device. So we're, as I said, using the connection network CLI, and you can see this is going to show some information about the interface. It's a very basic playbook, but it shows one thing that I find interesting is that we have a _command module for iOS, which means we're going to be able to run the commands that we're used to that are probably laying on a shell script today, and that maybe, I mean, you know, the commands you use, you can just put them in a playbook and reuse them straight away. So that's what I'm saying when I'm saying it's kind of easy to step up to Ansible automation, because from the ground up, you can reuse what you have with the iOS, for instance, the iOS command module. But that, as it turns out, all of the platforms have an _command module. And that's something I find very neat, because it's built in a way that platforms are different, but their available modules are always include at least command, config, and facts. So now you can see already that you're going to be cross-platform, because you're going to apply that same logic. Of course, the commands are going to be different, but then that's not, you know, you're already stepping in the correct direction where you're managing your different environment with the same logic. Config will make a config change, no surprise. Command will run a command. And facts is interesting because it will gather information about those devices you're talking to. And this information you're going to be able to reuse further down in your automation logic. So like what type of switch it is, how many ports it has, and so forth. But it's not, you know, we don't stop here. Above these platform-specific modules that are built always the same way, we have platform-agnostic modules, which means that for some functions, for example, configuring network interfaces, we have a module that's going to figure out on its own what type of switch it's talking to, and then configure that. So you can now apply with one single module across a range of the supported network infrastructure. So that's even, you know, more abstraction, more managing a very diverse, very broad scope of different vendors with one single tool. One thing that I have learned recently, but is actually quite old, is that with some modules, you can use the aggregate function, the aggregate parameter of a module. And this is interesting because if you look at the lower part of the screen, you see how I'm defining these VLANs, right? Like I'm writing a YAML definition for some VLAN. And when you're using aggregate, you're going to be much more efficient than when you're using loop. So that's a bit more of an advanced subject. But at the same time, it shows you how I model the information about my infrastructure. I got something that's a list, and in that list, there's the VLAN ID, there's the name of the VLAN, and sometimes, if I want, there's the state. This is really the definition that I'm going to apply to my infrastructure. And here you have this notion of infrastructure as code. On the left side, you have this aggregate data that I was using. It's a YAML file, it's in Git. It defines the states of my VLANs, their name, it defines interface data. And on the right side, you've got a very simple playbook that will take this data and apply it to something in the inventory. What it means is that I can take this data and apply it to data center A or to data center B. But it also means that I can take another version of this data file and applying to data center C with the same playbook. So like the flexibility that comes from this is really mind-blowing because you're doing, the work you're doing applies so many times across the different layers, and again, everything's in Git. One last bit of information I wanted to say is that above these modules, so we've seen platform modules, platform agnostic modules, the aggregate parameter of modules. There's also something that's called the networking engine. And the networking engine it's a role that's available in Galaxy, that is created by Red Hat and that ships with a number of modules. So you can ship modules inside roles. And it's going to have a decoupled release cycle from the main branch of Ansible, faster. And it provides high-level network functions. That is, when you have network modules, you still have to write the automation yourself. With Network Engine, we aim to provide the ability to have very easy-to-use content. That is, configuring VLANs, that's something that everybody does. So we're going to be able to provide a high-level network function that's going to be called from this Networking Engine module. And this provides like the view of the Ansible stack for network management. So you have the Ansible engine is the same, it's the one you're used to, and then you have this logic that comes with modules and then Galaxy roles that ship to like have some easy to use right away content. Obviously, all this can be used with Ansible Tower, and that's also something that's good. That is, if you write your modules in an your playbooks in a best practice compatible way, as you have just seen, then you can easily manage them from Ansible, and then you can scale to isolated nodes, to isolated regions. You can have role-based access control to attack all this logic, which in turns enable one of the use cases I like to talk about, which is delegation. So sometimes you have a team, they want to know if a router has the correct parameter. They have to call the network team. Sometimes the network teams wants to know if a server is able to ping. They have to call the owners of that server because they're not able to log into it. So you can have this logic written in playbook, like dump my root table and check for this specific entry, display it. And that playbook, well, you can expose to a team that you really don't want to connect on your switches and give them the access to just read the content that they need to read. That's, I think, is a powerful use case, the delegation use case, where you're able to, and this can be done through the role-based access control model in Ansible Tower. Another use case is obviously requesting your network devices, like asking information about them and then outputting this information. It can be very difficult to parse the information that comes from switches because it's formatted for the CLI of that specific switch, right? And it's difficult to extract this information in an automated way, but it turns out we have a way to do that that comes with the Network Engine role I was just talking about. And it's a parser that's like written to extract information from the outputs of network devices. So when you do this, then you can have scheduled jobs that run, that produce documentations about your switch, and then you're able to control the drift between different stages of the documentations and so forth. Another very common use case is backing up switches configurations. So this is something that was very expensive. It's just there are tools that are used to back up switch configurations that apparently are super expensive, and you can do this in 3 lines of Ansible. Well, maybe not, maybe 5. Another use case, once you've done all this, once you've had all these automation steps made once after another one, then obviously you're going to take these networking workflows and you're going to integrate them into a broader automation workflow. So this would be end-to-end provisioning of an application. So it's going to be able to create the ACI security zones that are needed for this specific application to communicate to the peers it needs. So you can have the end-to-end automation, including network, and it can also all be integrated from another type of service desk. Now, let me take it all together. I'm a little bit ahead. I rushed a little bit, so it's going to be actually good because I'm going to be able to take time to talk about this one, which is my favorite part of the networking with Ansible. So here I have an inventory on the left, and this inventory, as you can see, is a very simple one, but it describes my network topology. And this is in Git. So I have my data center A, it's built like that, and it's stored as a release git commit in my source control system. Attached to this inventory, I have variables, group vars, host vars. So this is a very standard Ansible mechanism. And inside this, you would have the aggregate values that I showed you earlier. So you would have the YAMLs that show the name of the VLAN, the speed of a given port, some parameters. All your configuration is described in these. So that's the data model part. Now, what this enables you to do is have a proper Git flow for network management. This means that if I want to change the name of a specific VLAN, I will go into Git and I will write a pull request, create a pull request saying, I want to change the name of this VLAN. This, if you're familiar with Git, needs to be then merged into the master branch, the releasable branch, depending on your Git flow. We can have network code reviews. That is, the team can come together and then reviews the different pull requests that have been made by, member of the network team. So like some clients actually have a scrum, a network scrum, where the network team is like, all right, you know what, like this part we can do now because this creates the communication that you need within team. Someone knows something that the guy who did the pull request doesn't know. Well, they talk about it during the network code review. Then they can decide that some of the changes will be applied and some of the changes will be rejected for now. Maybe we need to test them in a test infrastructure where we deploy our network changes before we push them to production. So that's also a thing. Some clients have either physical network testing infrastructure, that's cool, but it's a bit expensive, or some network vendors allow you to have virtual appliances for your network devices. In which case, you can build the layout of your network with virtual machines. And obviously, that's where it gets really, really good, is that the layout that you're going to build, you're going to derive from your inventory topology, right? Because that's how you know the structure of the network you're deploying to. Once everything is integrated, you now have the ability to deploy network changes in production and test them before you deploy in production. You can have a CI/CD pipeline for your network changes. That's really the ultimate goal. Some clients actually do automated network changes because they validate that this network changes passes all the tests that they need through a test pipeline. That is, when someone does a pull request, for example, if it's a VLAN change on a topology that they know is not critical, you obviously can tag differently on your different topologies, and then this pull request is automatically accepted into a test branch where it's validated against a set of tests, and if it passes correctly, then it's automatically merged to the production of that specific branch. Not the case for all the VLANs and all of the enterprise, obviously, but it gives you a sense of how flexible you can go with this logic of really managing network as code. And that's me. Thank you very much.
To see if there's any questions.
Oh yes, obviously. Does anyone have any question? There's
Are there any
6 minutes we have. Yeah.
So obviously Ansible uses SSH as for the connection method. A lot of devices might not support SSH in older networks. I've been reading about Ansible over SNMP. Do you have anything you can?
Ansible what?
Ansible over SNMP.
Ansible over SNMP. I don't know about that.
We can have the connection plugin if you have the SNMP connection plugin.
Apparently it's a thing. Let's talk about it later. Okay. come see me at the break and we'll have a discussion and I'll learn things. Anyone else? Yep.
Talk about using Git for all your configs.
say about using Git to push all the configs out, but are you pushing that up to GitHub, or have you got a local?
No. Yeah, I mean, you could, but that would be, like, then you'd have to vault everything, and then I mean, you're obviously usually using inside the company, private Git control system. So it can be, like this part of it, we don't really care about. If you integrate with Tower, then Tower supports a number of source control management systems. So it goes from Subversion to Git, or even to flat files, but that makes no sense in that case. But yeah, a private infrastructure block. That is actually critical to really automation and a lot of things. Yeah. Or Googs is an open source one. GOGS, G-O-G-S, free open source Git system. Anyone else? Yeah.
In the middle.
General question. Will you make slides available after the event?
I think so.
Yes, we will. Thank you. Don't get up.
We'll let you know.
Is there any dynamic inventory with things like CDP where we can just hit one main switch?
That's a good question, because I failed to mention that it was on one of my slides. But yeah, I mean, like I was talking about getting the inventory from a topology in Git. That's very good, but sometimes your network infrastructure is already defined somewhere in a CMDB or in a IP address management that's like been enriched with metadata and so forth. So some pre-existing dynamic inventory exists. So like if you want to get, if it's a ServiceNow CMDB, then you can get a pre-existing inventory. It's very easy to write and adapt your own dynamic inventory. This is like one of the first things that you do outside of just writing playbooks, and it's like very easy. It's a simple Python script with a very simple JSON output. It's very, very interesting to, I mean, you know, like, because like the question is then, is your enterprise CMDB up to date? And then we're going to go into another discussion, which is which one is the source of truth? Like, is there some of the clients I see, their CMDB, they don't rely on it. Like the network guys, they want to update that CMDB from what they discover with Ansible rather than pull down from the CMDB. But then you can do both things. You can have a dynamic source and a static place, a Git place where you store the group vars and the host vars. So you can get best of both worlds by using multiple sources for an inventory. Like in Tower, you can have inventories with multiple sources. Yeah.
So what you described is like directly from administrator perspective, the network admin is doing himself, but the manager of that admin, there might be tickets open somewhere, let's say Jira. So how would a manager can see what the guys are doing?
Yeah.
We have some sort of a GUI interface which can tell this ticket is attached to this task, and this is the status of the task, closed, open, or pending, whatever.
So from what I've seen, like the really core network automation, this is something that the network team likes to do themselves. And then they will expose some of these functions to other part of the enterprise. Like they will allow the enterprise to consume some of the automation that they have written for their own network, right? And this is done through a larger framework that can use Ansible Tower as an API provider, for example. The desk itself, it could be some sort of like, it could be Red Hat Platforms, it could be ServiceNow. But then inside that workflow, you will open a Jira ticket. Like a playbook can open a Jira ticket, can open a ServiceNow issue, can close it when it's revolved, but that's really not part of the core of the network thing. It's more a global, how do you build your automation inside that enterprise ecosystem? Like which API do you integrate to? Like what are the policies in place for that specific enterprise and so forth. So the network, they will provide the APIs through Tower usually for something they have done, and then this will be integrated in the global framework.
Okay, thank you very much, David.
No problem.